Hey students, I just wanted to record a video so that you know what's going on this week for science. We're working on investigation 2, week 1. This is the week of October 19th to October 25th. Here we go. The first thing we do in class is a self-reflection. And we reflected about how did investigation 1 go for us? Did we feel like we learned? We were supposed to be learning about how to define an organism and about the 8 characteristics of all life. Did you learn it? Think about it. Why is it important? We filled this in together. It helps us to know if something is living or non-living. It helps us in our study of biology in the future. For success, you should see what you can write to show that you learned. So you could talk about what the characteristics of life actually are and say, oh yeah, I know what they are. I learned there needs water, needs energy, reproduces, gas exchange, and list them out. Or you could talk about your project that you did. Oh yeah, I totally learned. I argued that an egg was non-living and I gave all of this reasoning and made a great point. It asks you some more questions about how the project went, and I want you to tell me how it went for you. It's okay to be honest. If it went good, if it went bad, let me know. Do you feel your grade accurately reflects the work you put into it? Tell me about that so that I know if you feel like you were graded fairly. It's good for me to know. If maybe you put 3 hours of work into it and you got a C, that doesn't really quite seem fair. So it's good for me to know. If you did not complete the project, what's your plan for getting it done? So fill in your plan. And here are the learning statements for our current investigation. We're learning about the microscope. So we're learning about the parts and the functions of a microscope. We're learning about magnification and field of view. And if those things are very mysterious to you, that's great because we're going to be learning about it. We haven't learned it yet. Why is it important? Importance. Many of the most critical living things and non-living things on Earth are too small to see with the naked eye. Wonderful things that decompose waste and turn the sun's energy into food, and even destructive things that can make other organisms sick or even kill them. The microscope has allowed us to see them, study them, and be astounded by their complexity. And how will you know you learned? What's the success criteria for this investigation? You'll be creating a presentation about the importance and history of the microscope. You'll focus on a discovery that was made and tell us all about it. Or, there's 2 options. Or you will design a functional microscope, a DIY, and you might actually physically design it, or you might more like draw up a blueprint for it and tell us about your design in your project. That comes during week 3. Okay, the next step we did, and we did this together, is we filled in the parts of the microscope. And the way that you need to do that on your doc is you need to double click on the drawing. When you double click on the drawing, it opens up and you should be able to type in the text boxes. So why don't you go ahead and pause the video so you can fill in the parts of the microscope. Okay. Once you have those filled in, you're going to go down and you can fill in the definition for magnification. Using lenses to make an object appear closer and bigger. Just like if you wear eyeglasses, your eyeglasses are lenses. They bend the light that passes through them, which sometimes it allows you to see farther away distance, which is like type of magnification, or sometimes it allows you to see up close, which I think is a different type of magnification. So eyeglasses are a great example of lenses, and microscope uses lenses too. So what you're going to do next is you're going to go to this thing called the virtual microscope. The blue link you need to click on. And then you're going to tinker around with this microscope. The first thing that it wants you to do is practice using the coarse focus knob to get each of the layers of ribbon into focus. So I see there's a red layer and I bring it into focus by making these adjustments. I see there's a blue layer and I'm trying to get it into focus. And then I'm going to try to get the green layer into focus. And I'm going to tinker around a little bit. I can use the fine focus to bring it into more precise focus. Okay, then I'm going to move on to the letter E. Down here you'll see the letter E. And the thing that you should do with the letter E is practice moving around this glass slide, your specimen. What happens when you move the slide away from you? What happens when you're to the image? What if you move the slide towards you? What happens to the image? What if you move the slide to the right? Which direction does the image go? And if you move it to the left, I said that backwards, but now I'm moving it to the right, which direction does the image go? Okay? The other thing is, does the E look like this E? No, what has happened? It's changed. All right, so you'll type the answers to those questions in your notebook. The image moves towards you, the image moves left. The E looks upside down and flipped left to right. Next, you're going to do the magnification section. And I'll show you what that is. It's also in the virtual microscope, actually. So let me just go back to the virtual microscope. And you're going to go down to where it says magnification. I'm going to keep trying to make it bigger so you can actually see it. All right, let's try this. So here's what you're doing. You're focusing on a millimeter ruler. So like imagine a teeny little ruler that's measurements are in millimeters. Millimeters is like if you hold your fingers so that you can just barely see between the two, that's a millimeter. And what's nice about a millimeter ruler is you can use it using a microscope because millimeters are so small that it actually can help you to get a reference point for how big are the objects that you're looking at. So if I focus my microscope on a millimeter ruler and then I count how many millimeters is my whole field of view. This is called the field of view. How many millimeters across is my field of view? Then it tells me if I have a little microbe under my microscope, I get some idea of how big it is. So here we are on 40x, that's low power. How many millimeters across is the field of view? So remember to count the spaces, right? Think about this like this is 0. Here's 1, here's 2, here's 3, here's 4. Okay, so then go back to your microscope and type that in. Or go back to your notebook and type in the answer, 4 millimeters, 4 mm. Then come back here and do for medium power. I would kind of move this around a little bit and then count how much space is in between. If this is 0, this is 1 millimeter, 1 mm, then you're going to have to estimate, about how much is that space? Is it a whole other millimeter? Probably not. How much is it? You're going to have to do the same thing with high power. High power is trickier. But take a look and see if you can guesstimate. It's obviously less than 1 millimeter. But how much less than 1 millimeter? That's what you'll have to guesstimate. Okay, so you'll fill those in to your notebook here. I did the low power for you, but you need to guesstimate for medium and high power. And I'm too zoomed in. So now I'm going to go down to this microscope measurement activity. Open it up. Looks like you have to log in. Which is Miss Troyer Science 105. It's at the top of every science notebook. So now what you do is you're checking out different slides under the microscope by clicking on them. Experiment with different magnifications by clicking on the objectives. These are the objectives. So if I want to try low power, medium power, and high power. Remember, low power is 4x, medium power is 10x, high power is 40x. So let's say I want to check out the brine shrimp first. So I get that under here. I'm taking a look. It's much better to start on low power and take a look at that brine shrimp. Okay, now let's see what it wants me to do next. It wants me to use a ruler to measure the field of view at each magnification. So I'm going to put this ruler under. And actually, this is pretty much exactly what we were just doing with the other thing. So that might make your job a little easier. Okay, now it's under. And want to start on low power. How many millimeters? Type it in here. And then do the same thing for medium power. How many millimeters? Type it in here. And for high power, how many millimeters? Type it in here. It gives you the answers so you can check and make sure they're correct. Oh, it wants me to correct them. Okay. Kind of makes your life easy. I mean, it makes sure that you can get to them. Estimate the width of the amoeba. So now you're going to stick that amoeba under here. I guess you just click on it. And now you have to think about, okay, well, if I'm on high power, what was the field of view? About how big is the amoeba? So you're going to walk through all these steps. When you get to the end, you'll see a screen that has green check marks if you got them correct, which at this point you should, because it basically makes you fix your answers if you don't. And you're going to screenshot it. So you're going to take a screenshot. There's also a button on your keyboard to take a screenshot. You could also Google how to screenshot if you don't know. And then you're going to insert that screenshot into your document. Insert the image, upload the screenshot I just took. That was not the screenshot I just took. And it says make sure that you do the completed activity with all the green check marks. Okay? When you're all done with that activity, you're going to insert that screenshot. The final thing is a microscope video. You answer questions as the video goes. Just click on that video and you can figure it out as you go. And then write 3 facts about the microscope that you learned or found interesting from the video. Send me a message if you have any questions. As always, I'm here to help you. So let me know, okay? Bye-bye.